So I'm super thrilled about following Wilfred. Ioda's angle is one of the most, I think, innovative things happening in the whole decentralized ledger space. Even the word decentralized ledger is getting stretched by what Ioda is doing. So I'm going to talk to you about decentralized identifiers, and when Antti called this, the building blocks of the decentralized world, this whole session, I said, this is the atomic building block. And this whole presentation is explain why. So I wear actually 5 hats. I only fit 3 of them on this. At Everdom, I'm Chief Trust Officer. The Sovereign Foundation, which is the nonprofit governance foundation for the sovereign ledger and ecosystem, is a separate nonprofit, and Phil Windley is here as and is speaking in a session tomorrow. He's the chair of the Sovereign Foundation. I'm also co-chair of the XDI Technical Committee at OASIS, so I work with Marcus, who will be presenting next. And the other 2 hats are actually also relevant to this. At the Decentralized Identity Foundation, which is doing open source code, think of it as a specialized hyperledger for decentralized identity, I co-chair the Identifier Naming and Discovery Working Group, which is building a resolver for decentralized identifiers. And the last one is at W3C, just in the last couple of weeks. The spec we're going to talk about here, the DID spec, has gone to the W3C and the Credentials Community Group, and I'm the co-author of that spec with Manus Forney from Digital Bazaar. So let's pop into this. We rearranged the order of these talks. Actually, Marcus and Wilfred and I got together down in Tallinn and said, wow, it's actually pretty remarkable how well these 3 building blocks that he picked out fit together, because Wilfred just covered really what you need for decentralization at that lowest level, that almost TCP/IP level. I'm going to talk about what you need at the identifier level, which plugs right into that and then enables private peer-to-peer decentralized data exchange, which Mark is going to talk about. That's what the XDI protocol is really all about. So, we actually then came back to Antti and said, let's do the talks in this order. So, self-sovereign identity. This is the definition I've been using as I've been talking about it at many conferences this morning. I'm not going to take time to read it to you. You can all do that. But it really is new. We've been surprised at how much this term is actually stuck out there. I have people come up to me at conferences and go, I want to do self-sovereign identity. I'm like, where did you hear about this? And the question, what's fascinating is, self-sovereign identity is only going to be possible with a new type of identifier that until about a year ago didn't exist. Oh, I can come back over here. Very good, that'll let me do a little bit more. I also don't want to step on this computer and feel like I'm going to destroy about $2,000 worth of value with the wrong step. Okay, so again, this is an entirely new type of identifier. And I've been working on identifiers for about 20 years. So when the origin of this actually came out of the W3C payments working group that said they needed a new type of digital credential, which I'll be talking more about tomorrow, verifiable claims. And in order for that new type of credential to be decentralized, they needed this new type of identifier. So they came up with the term DID, and that's what got it started. So this is what we need to enable truly decentralized identity that doesn't require any third party. And the reason those identifiers need blockchains, any blockchain technology, including IOTA, it's because that's the kind of decentralized system you need to register this kind of identifier. We will be talking, if you're thinking about the analogy with DNS and how it's like and how it's different than DNS, yes, you're on the right path, and I'll try and highlight as we go through this the differences with DNS. Okay, so DIDs. What is it? So resolvable, meaning if you have a DID, just like a URL or a domain name, you can go look it up. Okay? I'm going to talk a little bit about how much it's like a URN, Uniform Resource Name. Those things have been around in internet architecture for the last 20 years. It's a unique identifier you can use for any type of object. It's globally unique, but it's not resolvable. Your system has to know, well, what connects to this actual identifier. With DIDs, they're resolvable. You can go look them up on a blockchain. Okay? Secondly, they don't require any centralized registry, okay? You don't have to have infrastructure between you and the blockchain you're working on. And thirdly, cryptographically verifiable ownership. Those are the three unique things about this new type of identifier. All right, so let's get very concrete. I'm going to tell you right now, there's good meat in here for the developers. This one is sort of in between where Wilfred was and where Marcus is going to go, okay? For those of you that are not as technical, don't worry about it. You're just going to, see some of the sausage being made here. So I wanted to show you this for the developers that are here. This is the standard syntax for URNs. This is, I think it's, if I remember, it's RFC 2141. This has been standardized for, I think, 15 years out there on the web. If you want to identify an object with a global unique identifier that no one else is going to be using, and you don't want to use a central registry. Now, URNs, there are many different kinds. In fact, there are centralized URNs, they're decentralized. This particular example is a UUID. It's one of the most common things in decentralized programming, and you don't need any registry. And this is just a way to express a URN as a legal URI for the web. But this basic pattern of that's the URI prefix, that's called the URN namespace, and this is the actual identifier. In that case, it's 128 bits serialized in hexadecimal with these very strange placed dashes. Don't ask me to explain that. That was the pattern they came up with. All URNs fit this pattern. There are probably at least a dozen different URN schemes out there. You can go read their specifications out there. What we realized for DIDs is we could take that same pattern and adapt it to what we needed for DIDs. So the DID scheme, this is not yet an officially registered IANA or ICANN scheme, but we do intend to eventually do that. That next section we call the DID method name. And then this is called the method-specific identifier. One of the questions I get very frequently is, well, how is that determined? What's the way that's generated? And the answer is, the definition of that, how it's determined, is defined by that method. So a DID method turns around and says, this is how a DID will work with a specific ledger, okay? And there may be more than one DID method for a ledger such as Bitcoin or Ethereum, okay? So it's all about, with DIDs, it's all about a separate specification called a method specification. Just a URN say, here's how all URNs work, and then you write a URN specification for UID. Same thing here, you write a method specification for something like Sovereign. So these are the 4 DID method specifications currently under development. And when I say under development, active teams working together, almost all of them in the Decentralized Identity Foundation, working on the actual resolver code for these different methods. And also then working with the W3C on feedback into the DID specification. If you're looking at this and you're saying, oh, I'm interested in this. I've got a ledger technology, I mean one that's not listed there yet. Looking at Wilfred as IOTA, right? Hopefully that's, it's not rocket science to create a DID method. In fact, let's go take a look right. Oh, that's right, I put this, so the key point here, and I'm not going to go into all, this is a slide we use to talk about different types of ledgers out there. The DID method can be created for any distributed ledger. You'd have to have an extremely limited or specialized ledger that couldn't be, you couldn't do DIDs for. Now, I wanted to highlight IOTA as, our new partner that Evernym is working with on this, a totally new take on permissionless ledgers, and but one that, the whole basis for our discussion is, oh, of course, they can do DIDs, and in a powerful new way. This segment here, the public permission, is, in contrast to pure permissionless or pure permissioned private ledgers. This is where Sovereign and also IPDB. Is there anyone from IPDB or BigChainDB here today? Okay, they're based down in Berlin. They also use a public permission ledger for a globally distributed database. So I just want to highlight again, DIDs can work with any of these. You just need to write the method. So what does a method spec cover? 3 things. First, you're going to define what's the syntax of that method-specific identifier, how's it generated. Simple example, in Sovereign, it's the first half of an ED 25519 verification key. And then it's base 56 encoding. That's how Sovereign does it. It says you create a key pair, take the verification key first half, encode it this way, and that's your DID. Okay? The Bitcoin, the BITCR method says it's the address of the transaction you're going to put on the Bitcoin ledger. Plus, there's a second piece to it. I can't remember precisely what it is. Okay? In Ethereum, the Uport method, it's the address of a smart contract on Ethereum. In every case, it's unique, it's resolvable on the ledger, and it's not human readable at all. Okay? This is not about naming. I'm happy to answer questions about naming when we get to the panel later. Okay, so your method spec has to say, here's the syntax and how you generate that identifier. Then if there's a portion of the DDO I'm going to talk about in a minute, if you have any special rules about how the metadata associated gets updated on that ledger, they go in the spec. And then lastly, you have to define the CRUD operations. How do you create the DID and the associated DDO? How do you read it? How do you update it? And you don't actually delete it because these are persistent or immutable transactions. How do you revoke it, right? Key revocation. So let's look at a DDO. First, a quick, the basic idea is key value, we're using ledgers as key value databases. Very, very simple from that standpoint. The key is the DID, the lookup key, and the value you're going to get back, we call it a DDO, DID descriptor object, and it's a JSON LD object, designed to be very simple. You think of it as very much like returning a record from DNS, an IP record, MX record. Very simple, a little bit more sophisticated, and definitely more extensible directly than DNS. So this is a list of the 6 basic things that go into DDOs. The DID is in there so it can be self-describing as a piece of JSON LD. The public keys, I'll talk more about this in a minute. Service endpoints, this is how you're going to take the DID, get the DDO, and be able to then contact and interact with that identity owner. Be it a person, be it an organization, be it a thing. Okay? I'm going to talk about that a little bit more because that's obviously where we fit into using a protocol like XDI. There's another special section in there which is for key management, controlling DIDs. Who can control changes to this? How would you do key rotation or key revocation? Okay. Then there are timestamps for auditing, and then optionally a signature for integrity. One of the reasons it's optional is because if you get back this record, you can actually, in real time, send a challenge to that endpoint and get a response back, so that you know you don't need any key revocation or OSCP protocol. You can verify in real time that that endpoint is live and can answer a challenge and verify its public key ownership. All right, let's actually look at the guts of a DDO here quickly for all the developers in the audience. I'm not going to spend a lot of time on this, but I do want to show you this is what they look like. It's 3 slides long. That's the JSON LD context. This is the DID being described right here. This happens to be a sovereign DID in this example. And these are the 2 public keys in this case associated with it. Each of these blocks is called a key description. In turn, that is an ID of that key. Now it uses something I'll talk about in a minute called a fragment. Notice the address is the DID plus a classic fragment, as with all web architecture. That address can be resolved exactly to that key. It's immutable, it's forever, and on a ledger, whatever ledger, you can now prove exactly the time period in which that key was introduced, active, and if it was revoked. All right? For all you folks out there going, oh, this is changing PKI. Yes, you're exactly right. That's where we're going. Okay, now, second part. This is the control block. It's a very simple example of what a control block method would look like. We call this an OR control. It says these 2 DIDs, either one of them can talk to the ledger and change this DDO. Do key rotation, key revocation, or revoke the whole thing. The logic in this control block is defined by a DID method. Different DID methods are going to support different forms of key management. And then this is the service, what we'll call the service block. This is where you find out how can I talk to and where can I talk to the identity behind this. And again, I'm going to highlight this is where, when Marcus talks, you will find an XDI endpoint if that particular identity supports interaction via XDI. All right. Lastly, we have the metadata created, updated, and again, optionally a signature on this. So you can verify the integrity of that particular DBO. All right, I'm going to, couple last things. Really critical thing we found in designing DIDs, which is everyone's familiar with the overall need for delegation in digital identity management. We need it all the way down to the level of DIDs. How can you have a DID for an entity that is not able to control its private keys directly? Okay? DID, self-sovereign identity, is for all planet Earth. Sovereign Foundation, its logo is identity for all. And especially the quarter of this world's population that does not have legal identity today. This is UN Sustainable Development Goal 16.9, to give everyone in this world a legal identity by 2030. And Sovereign Foundation, just as you saw Wilfred talk about what IOTA is doing there, we're on the same track. We just formed an Identity All for committee to go after this. These identity owners initially are going to need guardians, whether it's an NGO, it is a family member, it's a web of trust model. It doesn't matter. They're all supported. Okay, and when you have a DID under guardianship, what you will not see is any public keys here. Instead, you will see a guardian. And by the way, that is going to change to be a list, an array, because we've already got use cases that require multiple guardians. Okay, I think that's all of the super deep dive. I'm going to wrap up by one more point for the developers. As I pointed out earlier, paths and fragments are supported with DIDs. DID is a valid URI, and if we go where we think we're going, you're actually going to start to see these supported directly in the browsers, and which of course is going to lead to things like DID authentication, right? Supported right in the browser. All right, I have one more section here. I want to make this a really, really important point. A lot of folks look at DIDs and go, wow. To use Anti's point, IP addresses for people. So yes and no. Yes, in that it's identifiable and resolvable in the way of an IP address, but and maybe the analogy is good with IPv6 addresses. The point is, these are also designed for privacy protection. From the outset, it's not an accident, okay? So that's really a requirement of self-sovereign identity infrastructure as a whole. So number one most important point when you're thinking about DIDs and individuals is that you won't have just one. This is explicitly developed to support the recommendation of GDPR that you use pairwise pseudonyms wherever possible, okay? So with individuals, think I will have a DID for every relationship that I need to develop. Now, if your first reaction is, oh, how would I ever manage that? Well, I'm going to turn around and ask you right now, how many people know the phone numbers in their mobile address book right now? How many people think that they can tell me more than 10 phone numbers, the actual numbers in their mobile address book? Put your hand up. Okay. Yeah, I know. Okay, my point is, these are going to be managed by software agents, okay? We're talking about infrastructure where you have to have agents and software that's under your control, that's using secure elements on your phone, HSMs on servers. This is key management that's under your control, okay? Every DID is actually the endpoint, or can be the logical endpoint for an encrypted connection, okay? And I know I'm running out of time, so I'm just going to quickly go. I want to help introduce Marcus's presentation by thinking about this stack this way, okay? Down at this layer, the DID layer, that's where you've got your ledger, that's where you've got an IOTA or whatever the ledger is. The endpoints that you're connecting to in the key management architecture we're connected, we call this the cloud layer. That's where your endpoint sits, someplace in the cloud, whether you run it or anyone else does. What you've got on your devices is the edge layer. Also, agents and wallets that are able to talk to the cloud can talk to that, and that's what identity owners are interacting with directly. And what Marcus is going to talk to you about is what's going to be possible over this. And so really think about this. Every DID is the endpoint for a peer-to-peer, encrypted, verified connection, okay? You don't know at the outset how you can trust it, so in my talk tomorrow, I will talk about this is where verifiable claims can be exchanged in order to develop that trust. And that's also a W3C working group. So, to summarize, this new layer is like a cryptographic DNS, okay? Flat, can scale to the whole world, just like IOTA can, right? This is why we're doing this partnership. This is also called by a number of people, many people are now calling this decentralized public key infrastructure, okay? It is the decentralized self-sovereign version. And whether you're a developer or not, I'm gonna give you a simple mental image of to walk away from it here, okay? That is your self-sovereign identity tree. The tree of information that you want, and you want the MyData principles to apply to, right? Rooted in any distributed ledger. That root is a DID. The connection to that data is provided through the DDO. And that tree of rich, textual, cryptographically verifiable data can now live behind a private endpoint and interact with anyone else in the world. That is what it's going to look like. And that, I believe, is going to be the MyData ecosystem. And for the developers, there's the links. They're in the thing online. And I do want to, by the way, always acknowledge that this actually, the DID spec was funded by the US Department of Homeland Security. And I know, over here I feel a little bit sheepish saying that, but actually they're very progressive and they're contributing to this work. And Anil John, the program manager, says hi to everyone. All right, tomorrow part 2.
All right. Thanks, Drummon.